In this video, we will be discussing about modulation and what is the need for modulation. Why did the need arise for modulation? Now, say suppose you have 20 hertz. You have a signal of 20 hertz that you want to set. Now, because of this 20 hertz, you have a wavelength which is comparable to around 15 kilometer. So, in a way, we need an antenna of this size. We need an antenna that is of this size. So, building an antenna of this size to transmit a wave of this size is practically not feasible. So, therefore, we need to modulate. We need to modulate. Therefore, the necessary need for modulation came. And there were certain other factors also, like effective power radiation by antenna. If you want, see, this is a frequency that is low as compared to some other frequencies. So we know that energy is equal to h nu. So if energy equals to h nu, we know because of this low frequency the energy will be less, and because of this there will be loss of energy while transmission, loss of energy. So that is also another reason for the necessary ask for modulation. And the another factor that you will come across is that now because of this, say suppose because of 20 hertz you want to send a signal, and certain other, say a station, radio station wants to send the same song. So this is another 20 hertz. Now while they are going, they combine with each other and they have a resultant wave that is the vector sum of this wave and this wave. So now we will hear something else. We will hear something else. Something else. So in a way we are afraid of this mixing of these two waves, and therefore because of all these conditions we have come to the conclusion that waves should be modulated. So now if waves should be modulated, you know there are two types of modulation. One is that you can change the amplitude of this wave. Now a carrier wave is there. Now if you increase the amplitude of this wave and you put the small wave inside this big highly amplituded wave, then this type of modulation is known as amplitude modulation. Amplitude modulation. So we'll discuss this in a later part of our slide, but for now, amplitude modulation. The second type is instead of changing the amplitude, you change the frequency. That is frequency modulation. And now frequency modulation. Now frequency modulation, we know if you increase the frequency, the energy increases, and so it can travel huge distances with less loss of energy. So these are the two types of modulation that we know of. There are different types, but for now you need two types. So we will be basically discussing in this chapter of ours how amplitude modulation is done and how we can use this amplitude modulation in transmitting the waves with less loss of energy. So let's have a look in our next slide about amplitude modulation. So in my previous slide, we had established the condition that is necessary for amplitude modulation. Now let's look at amplitude modulation itself. So what happens in amplitude modulation is, say suppose this is your carrier wave. Say this is your carrier wave and this is your signal. This is your signal. So now you have to make this travel through a long distances. So now what happens is the amplitude of the carrier is varied in accordance with the information signal. Whatever is the information signal, we will vary the amplitude likewise. We will generate a carrier wave and we will change its amplitude so that it in a certain way it matches with the signal or the information that we are trying to send. See, let's say because this is a wave, so as we have discussed in our previous section, we can express this in our, that is, we can express this in an equation. Wave can be expressed this in an equation. So let my carrier wave be AC, this is carrier wave, this is C, AC be sine omega ct, that is angular frequency for the carrier wave. Now let there be another wave, that is message. So for message I am writing, now please keep in mind this will depend upon the time t, therefore I am taking the function for time t. So my information or message can be written as, I have taken this as AM, amplitude of my message, into sine omega m into t. So this is for my message. Now if you look, what is Wm? Wm is nothing but your twice pi by time period. And what is time period? This is nothing but time t is equal to 1 by nu. So this we can write as twice pi f. Frequency of your message. Frequency of your message. So this is what is given. This is what is given. So angular frequency is equal to twice pi into f. That is frequency of the wave. So now, say suppose you are writing this Cm of t. Now this modulated wave. So initially the modulated wave, after we have done the modulation, so this is C. This was my carrier. So after I have done the modulation, that is Cm with a function of t is actually equal to what is this? AC plus AM sine omega t. Now after we have done the modulation, after we have modulated, we have increased the modulation and we have put in the frequency, Now what we have is this is the amplitude of the modulated wave into sine omega ct. That is, this part will remain constant. If you look, this part will remain constant. We are just changing the carrier wave. We are changing the modulation of the carrier wave. How we are changing? By taking this AC, that is the amplitude of the carrier, plus AM sine omega t. So this is the complete amplitude of the modulated wave. Amplitude of, let me use a different color, of the modulated wave. So this is so far that we have established. So now for calculation part, just look over here. This is what AC plus AM sine omega t whole. Now this is whole bracket. Keep in mind whole bracket into sine omega c t. Now let's say I take a common. Therefore Cm of t. Let's say I take a AC common. AC, that is amplitude of the carrier wave common. If I take a AC common out of here, what I will have, this is 1 plus AM message upon AC. This is upon AC into sine omega t into sine omega ct. Excuse me. Now this omega is m. So this is what I have. So now if you note that the modulated signal now contains the message signal. Now you will see that the this modulated signal contains the message signal as well. So that we have already discussed. So in a way we can write C modulated T is actually equal to AC. If I multiply this, I'm multiplying this. Just keep in mind I am multiplying this. AC, this multiplied by this multiplied by this. In your book they have skipped one step, so I want the students to understand this, what they have actually done. Let me write this in a different color. So I'm writing this in blue color, AC sine omega CT. This is my first, plus, if you look over here, this is, it is given mu. Let me explain this afterward. This is AC sine omega mt into sine omega CT. Now, what is actually mu? Mu is nothing but your, this mu is nothing but your AM upon AC. This is nothing but your AM upon AC. So this mu is nothing but AM upon AC. So this one gets multiplied over here. AC into mu. We have AC. This is my AC into mu. This is my mu into sine omega mt. This is for the message into sine omega CT. This is for the carrier. So this is how our wave will look like. So this is what you can understand from this. Now let's do further simplification in our next slide. Now this is what it actually looked like, where mu is given by, mu we had already established as AM, amplitude of the signal, upon amplitude of the carrier. Now you should always keep in mind this mu should be less than 1. Should be always less than or equal to 1. Why? Because if it is not so, it will start distortion. It will start distortion. It will start having distortion. So we should always have the amplitude of the message less than the amplitude of the carrier. Now this is what we have. Now it is further simplified. If you notice this, this is further simplified by using another trigonometric ratio. What is this? If you look over here, omega mt omega ct. Let omega mt be A and let omega ct be, say, B. So this particular thing becomes sine of A into sine of B. This is nothing but sine of A into sine of B. This in your book has been further simplified as half of cos A minus B minus cos A plus B. So this is what has been used in your book. So if you use this trigonometric identity, then this particular, now keep in mind this is omega, this is A and this is B. So we are just taking omega mt minus omega ct, and this is omega mt plus omega ct. So your final equation after simplification becomes AC into sine omega ct plus mu AC upon 2, because this becomes 1 by 2, into omega c minus omega m into t minus, this is minus again, cos, now this will be in whole, cos omega c plus omega m into t. So this is your final equation that you can have. Now what about this omega c omega m and omega c plus omega m? Now this term is also named, or this term is also defined. Now omega c minus omega m is called the lower side. This is called the lower side. And omega c plus omega m is called the upper side frequency. This is upper side frequency. This is called lower side frequency. So this is how we know. Now if you notice, the modulated signal now consists of the carrier wave of frequency omega c plus also two sinusoidal wave, each with a frequency slightly different now. Now if you look, this has a slight different frequency. It has a frequency of the carrier wave plus also a slight different frequency. Therefore the frequency spectrum of the amplitude modulated signal can be shown. It can be shown in your book. You will see this particular diagram. So if this is mu a upon 2, you will see that for this omega c minus omega m, and for omega c plus omega m, you have this. In between, somewhere in between, you have the maximum. So for this too, you have mu a by mu 2 exactly same. So this is how we can understand. Now, as long as the broadcast frequency or the carrier waves are sufficiently spaced out so that the sidebands do not overlap, different stations can excuse me. So as long, now what in your book, in your NCERT book, what it is said is that, now see, this is a different frequency, this is a different frequency. Now as long as this two frequency and this two frequency do not overlap, so, and they remain in their bandwidth, and they remain in their bandwidth, say suppose they are in their bandwidth. So depending upon the transmission, depending upon different stations and what carrier wave they use, they can send this wave easily. That is, these two waves will not in any way interfere among each other, because these two waves have become a totally different waves with different angular frequency. And therefore that is the reason why we do amplitude modulation. Now what you have to notice is the main highlight of this amplitude modulation is that the broadcast frequency, the frequency at which we are doing the broadcasting or the carrier wave, should be sufficiently spaced out. Sufficiently spaced out means it should have a huge bandwidth. Or you can say that the amplitude should be great. The amplitude should be very much. If the amplitude is very much, then we won't be facing any problem.